Welcome to the Learning Vault. This clip is on vectors. Zero vector. This gives us a value of 0. A unit vector is a vector that has a magnitude of 1. The unit vector along the x-axis is written as I, and the unit vector along the y-axis is written as j. Position vector is a vector position relative to a fixed origin. So from the diagram there, if vector OA equals to xi plus yj, then the position vector of A is column vector xy. Equal vectors. Equal vectors have the same magnitude and the same direction. As we can see above, vector A equals to vector C. Parallel vectors. Vector A is parallel to vector C, and we represent it with a parallel line indicated there. Now vector B equals to negative A. So vector B and A are parallel, equal in length, but opposite direction. Now vector 2A and A are parallel as well. Negative vectors. Vector AB is represented by the column vector of x1, y1. Now vector BA is going in the opposite direction. So it's represented as -1 times the column vector of x1, y1, which will give us the column vector of -x1 and -y1. So vector BA is a negative vector of AB. They are parallel, equal in length, but opposite in direction. Scalar multiplication. Numbers such as 3, 2, -1 and 1/4 are called scalars because they have size but no direction. Now, vector A and 2A is an example of scalar multiplication. It is the vector A multiplied by 2. Now vector 2A and A are parallel. Remember, vectors that are parallel are scalar multiples of each other. Further views on scalar multiplication. We have vector A given as a column vector of x1, y1. In this case, it is column vector of 3 and 2. Our 2A, since it's a scalar multiplication of 2, we know that 2A is 6 and 4. Now our next vector, which is 3A, is a scalar multiplication of 3, so the vector 3A is 9 and 6. Remember, vectors are parallel, are scalar multiples of each other. Vector addition. We're given that vector A is a column vector of 6 and 4, and vector B is a column vector of 2 and -8. So A plus B is going to be the column vector 6, 4 plus 2 and -8. So our answer is 8 and -4. Now this is also known as the triangle law of vector addition because the vectors end up forming a triangle. Now if we have a vector like C representing vector A plus vector B, we call this the resultant vector of A and B. So it's represented as vector C equals to vector A plus vector B. So in summary, for vector addition, if we're given a column vector of x1 and y1 and another vector B of column vector of x2 and y2, the sum of the two vectors is going to be x1 plus x2 and y1 plus y2. Vector subtraction. We're given the vector of A as a column vector of 6 and 4 and B as a column vector of -2 and 8. Now to work out vector A minus vector B, we should remember and note that vector A plus the negative value of vector b, which will become a column vector of 2 and negative 8. So we now have the column vector of 6 and 4 plus the column vector of 2 and negative 8. This will give us a column vector of 8 and negative 4. Now let's start working from the left hand side. This time we have the column vector of 6 and 4 minus the column vector of negative 2 and 8, which will result to 6 minus 2 and 4 minus 8. This will still give us the column vector of 8 and negative 4, which is the same as the value we had on the right hand side. So vector A minus vector B gives us the column vector of 8 and negative 4. To summarize, for vector subtraction, if we're given the vector A minus the vector of B, we have it as the column vector of x1 minus x2 and y1 minus y2. Well done, keep on learning. Don't forget to click the like button, press the notification bell, and subscribe for more of our daily videos.